Hey, everybody there on YouTube. Welcome to the daily space weather and Earth weather stream. Had some interesting space weather indeed. A major coronal mass ejection of both high speed and significant density is headed toward Earth. So, expecting that to arrive sometime on the 31st, March 31st, that is, 2026. We'll talk all about it. We'll talk about things like the total electron content. And there is the total electron content at the time of the flare, by the way, which was around 3:20 universal time. Here's the animation. I could bring that back a little bit for you here. But there's the part of the Earth that was around noontime. That would be 3:20 universal. So, yeah, and you can also look at the deabsorption regions, the DRAP predictions, which I'll show you here in a minute. And this is because the X-ray flux, it causes the D layer to get attenuated and your radio signal goes into space. So here's the flare. It was an X-class solar flare. It was a small X-class event, but an X-class event nonetheless. So there you can see a bunch of blacked out radio signal. Now keep in mind, this is a prediction map. So this is not quite the same as if we were looking at an actual map of the total electron content. So this is the total electron content. This is the ions all the way from ground level. So not the same thing as the deabsorption region map, folks. And it should be playing, but it isn't because reasons. Let's try that again. There we go. So that's a global ionosphere map now. It's going to be showing you, that's the total electron content. So that is the free ions. I should say the ions. The ions from ground level up to the outer Van Allen belts. So where your geosynchronous satellites will be located. And these are all the ground stations that are measuring the signal refraction there. So yeah, this was, of course, a major solar flare. And more importantly, folks, we've got a major Earth-directed coronal mass ejection. So we're going to show you that as well here from the perspective of stereo A, and it looks pretty spectacular. So first of all, here's the solar flare. We're looking at GOES 19, 304 angstroms. And there's that X-class event. Again, like I said, peak flux was around 320. Keep in mind it was about 8 minutes before that because it takes about 8 minutes for light to get to Earth from the sun. I'll play that through a few times for you there. In fact, how about a nice zoom? There you go. Here we go. 3, 2, 1, flare. So, yep, peak flux was around 3:20 universal time this morning on the 30th. And there is an Earth-directed coronal mass ejection. It will cause major geomagnetic storms, so don't be surprised to see mid-latitude aurorae where you're located. If you're doing polar flights and you're an astronaut or something like that, expect increased radiation exposure when it arrives. And it's high speed, so as per Tamitha Skov, expecting this one to arrive tomorrow. Major geomagnetic storm is now in everybody's forecast. So yeah, like I said, 320 was peak flux. There is the X-ray flux. And man, I thought I'd see more viewers tuned into the daily space and Earth weather today. We did come a little later because I had to look at some data that I don't always look at. So, but in any case, so there's a 3-day X-ray flux, and we were pretty much in a quiet situation here uh, since Saturday. We only had one M-class event then, and then only C-class intensifications until this X flare. So there you go. Big solar flare. It was a class X1, X1 and a half, X1.49. So not a super huge flare there, but located in a position where it was able to eject material, or associated with the flare is the ejection of material, as we don't want to causally link a flare and a coronal mass ejection. So we've also got coronal holes on the sun right now. There's the latest image in 211 angstroms. And coronal holes are where the solar magnetic field lines are just pointed out into space. Instead of being all tangled up in a thing like a sunspot, this is sort of the opposite of a sunspot. A coronal hole features, instead of tangled up lines, it features magnetic field lines that extend all the way out into the greater solar system. So anyway, here is the closest star in terms of sunspots, and we have a major conflagration of sunspots. So not too surprising to see an Earth-directed CME with this much action on the Earth side of the disk. And no surprise to people who understand solar cycles, because we're still seeing quite a large latitude difference here. As we get closer and closer to solar minimum, you're going to see less and less high latitude sunspots. Sunspots, as you approach solar minimum, they will get closer and closer to the equator. And so this shows us that we are quite far from solar minimum. We can expect to see plenty of more action in the coming year or two. So anyway, we're about 18 months beyond solar maximum. That occurred around November or December of 2024. And still seeing hundreds of sunspots. Here are the magnetic fields. And as you can see, this group down here is quite impressive indeed. Quite impressive. So if I add, I'm going to add 171 angstroms just to show you the ultimate sort of combination here, because you'll see the umbre, you'll see, oh wow, there is major magnetic shear there too. So this should be interesting. There's 171 angstroms, and that'll help to show all the flux ropes and so forth. There we go. There's just the magnetogram plus 171 angstroms. So not only is that sunspot absolutely massive, again, there are just the umbre. And you see the way these are real boxy looking? That is not a common type of configuration of those umbre. All right, so this is like, there you go. There's the Earth scale giving you an idea of how huge that southern sunspot is. But there is a lot. I mean, you can see there's a plasma bridge. And there's a big plasma bridge right there, kind of stretching across that umbra. So that is a quite a hefty and complex sunspot group indeed. There is the 171 angstroms. And let's actually, I'm going to put the continuum instead of the magnetogram, so you can see the way the field lines orient themselves. So there's a continuum. Wow, look at all that folded plasma right there. Look at that. That's like just a wall of plasma right there. Looks like a giant wave. Almost like a tsunami, which, by the way, we hope none were generated in the 7+ magnitude earthquake that occurred this morning. Moving right along, cosmic ray flux. You can expect to see a major dip in cosmic ray flux tomorrow. Yeah, that's a cosmic ray forecast, because we'll have a 4-bush minimum. So right now we're at a 22-year low for cosmic ray flux, as you can see on this graph dating back to 1964. Will be even lower. This is going to be one of the major impacts of solar cycle 25. So enjoy it, as you may be seeing mid-latitude aurora at your location. This is just one of the cosmic ray point sources, in fact, the only known cosmic ray point source, Cygnus X3 and its X-rays. Again, those are X-rays not to be confused with things like coronal mass ejections and so forth. These are a type of high-frequency photons, folks. So whatever you do, please do not conflate solar flares and coronal mass ejections. This is going to be a big deal. We're going to hear about this all day. Articles will be written that conflate the two. They are separate phenomena. So think of a solar flare like a dental X-ray. It's photons that you can't even see with the naked eye because they're X-rays. That's what a solar flare is, a sudden uptick in the solar X-ray flux. A coronal mass ejection is when the sun blasts a bunch of gas out of its corona or atmosphere. So very different. Think of a fan. Think of a puff of smoke or diffuse gas. Think of dry ice and the gas that you see. It's actual physical matter, not electromagnetic radiation like a solar flare. So solar flares are photons, like light, and coronal mass ejections are protons because they're gas. So I just like to bring that up, especially when there are major space weather events on the way, as there are now, since we'll hear about space weather and hopefully a whole new batch of space weather enthusiasts will be born, as they are so often when we have major Earth-directed CMEs like that one right there. It's high speed, it's high density, and a large portion of it will strike Earth directly. This is going to be a solar storm that lasts for days, and it could wreak havoc on communications, and it could wreak havoc on all kinds of things. Maybe the internet will shut down and benefit all of you people who will be forced to get off of YouTube. Just kidding, folks. We don't want you to not be able to watch the videos. So anyway, there's the Huxt forecast. And as you can see, everybody is in agreement. This is a high-speed coronal mass ejection that will have a large earthly directed component. Expect major geomagnetic storms up to a G4. Current conditions are, we've got some space weather afoot. Slightly elevated solar wind speed there at 464 kilometers a second. Solar wind density here, 2.5 protons per cubic centimeter. The rest of that is pretty nominal. Let's move on. And by the way, it's measured at Lagrange 1. So there's the orbit of the ACE. That's what's currently measuring. Let's just, for fun, let's look at the other instrument here. Let's look at Discover. Where is it? 9. We look at Discover only. Yeah? Yeah. So Discover is showing a much denser solar wind, but at a similar speed. So denser plasma there picked up at the Discover at 8.25 protons per cubic centimeter. Now we'll go back to the active spacecraft. I just leave it set to the active spacecraft. But you can set that up in different ways and make it look differently with a white background if you like, and all kinds of pretty things. The real-time solar wind, talking about real-world facts about space weather at the Space Weather Prediction Center. Again, the active spacecraft is currently the ACE, but we also looked at Discover. So over here at Discover, we've got a denser plasma. How about that? Here's Lagrange 1, where it's measured about 1 million miles from Earth. And we're about 1 million miles from having any viewers on this stream. So if you're viewing in syndication, thanks for tuning in. Congratulations on realizing the channel exists. We remain frankly surprised. And if you're new, don't forget to press the subscribe button. Otherwise, you may not see the world's most comprehensive daily space weather content delivered directly to your YouTube subscription feed. Please visit our links as well to support the channel by pressing the share button and visiting the homepage at smashomash.com. Least busted name in news. Let's look at the visible light imagery for once here from the Space Weather Prediction Center Space Weather Enthusiast dashboard page. There you go. How about that? We don't usually look at that, but let's cue it up for once. Oh, it doesn't function. Does it? Does it? What's up with that? Ugh. It looks like just a couple frames. I don't know. I don't know why it looks so koofed. But let's see what NOAA has to say about space weather. And they're only forecasting a G2 geomagnetic storm. So I find that a little bit, I think that's going to be amended, but we're looking at coming sometime around midday tomorrow. So it's going to be a high speed one, and I think it's going to be a little bit stronger than this. But let's see, what are they talking about here? Okay, they did notice it. So I get maybe they think the coronal hole high speed stream is going to weaken that coronal mass ejection. Let us know what you think in the comments. We're always interested to hear what our pals from YouTube think about the predictions. I think we're going to see a G4. I think we're going to get to KP8. KP 7.67. KP 7.67, folks. Anyway, there's the past 4 hours of the magnetosphere. Our geospace magnetosphere movie. Things are pretty calm in space weather at the moment, but not to last long, because by midday tomorrow on March 31st, there's going to be some space weather afoot. So solar stats continue. Radio flux has actually come down, interestingly, but it's still way up to about 158 solar flux units, as shown here at solon.info/solar. I would note to you, new space weather people, that the red line and black line are proportional. You can see how they're directly proportional to each other, meaning when you have high sunspot number, you have high radio flux, and vice versa, making the radio flux the second or possibly even the most important feature to monitor the solar sunspot cycle. Although since you're counting sunspots, maybe sunspot number is more important. So there's that. Sunspot number here leveling off at about 140 sunspots. 140 sunspots. That's what they look like. So let's take a look at this flare here. We'll use some different wavelengths. Here's 131 angstroms, and this will look great, by the way. Whoa, what? How is it showing the 27th? What? Oh my gosh. I guess it hasn't been, why doesn't it refresh? I guess it'll refresh on its own. We'll show 94 angstroms because we're going to load this manually. That's bizarre. All right, let's try this again. It'll look spectacular in this wavelength as well. And there it is. 94 and 131 angstroms are specifically to view flares. So look at that. You can see a bunch of plasma coming down here to the south. This actually splashes back down. So not all of the plasma ejected, and it rarely does. But we did have some Hyder flare action there, and an eclipse that was caused by the Earth. But it was just in time to not totally miss that flare. So yeah, that's a good one. All right. So yeah, sunspot number, baby. How about the coronagraph? Should be interesting. Now there is an eclipse in the coronagraph as well, so this is that's another one of them there, Earth eclipses. But you can see the halo here, and when you look at stereo A, it's pretty sweet, dudes. Pretty sweet, dudes. Check it out. If you like space weather, today's a good day for you, because look at that. How about them apples? Them are some pretty good apples. And we shared a screenshot of this already in our community posts. So if you haven't seen those, I don't know why. They should be on your subscription feed if you subscribe to the channel. But you can always see our community posts where we share even sometimes other channels' content at youtube.com/smashomash/community. Anyway, we've also got Venus in the frame there, which is totally sweet. And yeah, pretty epic. Pretty epic. A giant plasma cloud with a dense portion of it headed toward Earth rapidly. Rapidly. Anyway, here's where planets are currently located. Mercury has just made a pass, and Venus is on its way. So, yeah, did you hear who's ahead? You know who's ahead, right? You know who's ahead. Do you know who's ahead? I'll let you know. Cabbage. But the onions are coming up strong. All right, so here's the proton flux, and we ain't got no proton flux. There was none generated by that solar flare, and sometimes we even see spikes without a solar flare. I shouldn't say generated by the flare. I should say associated with. But anyway, we ain't got no spikes in the proton flux. Cheers. At least that's a little bit less radiation. We don't need to have polar radio blackouts, right? So far, no spikes in that proton flux. But don't be surprised to see more X-class flares. And frankly, as time goes on, the likelihood of a proton event goes way up. Like we're likely to see a big proton event. Happy Monday. It's an exciting way to kick off a week with major space weather on the way, folks. All right, so here's sort of an analysis of what the solar system's potential field surface source map looks like. That's basically the heliosphere and its magnetism. And we're showing more days than we need to here. Let's just show yesterday plus today. So Earth is still in a South Pole oriented coronal hole sector there. And I believe that's the elevated solar wind that we have right now. That's the South Pole oriented coronal hole high speed stream. So if we bring up the latest here, we should see that coronal hole sort of toward the west. No, just in center longitude there. Could still be North Pole oriented coronal hole high speed stream, but it's not very high speed. And look, this is opening up as we suggested may happen in previous videos. If you look at 195 angstroms, you can see that coronal hole appearing to get larger, but it might have just been stationary because, again, there is a lot of plasma suspended by these groups right here. And you can see it in that imagery there. It'll probably show up a little bit better in 304 angstroms, but this is a very bumpy section of the solar corona right now because there is a lot of strong magnetic field action, not as strong as down here, or I should say not as violent as down here, because this is a really, it's what you'd call a rowdy sunspot. I mean, I showed you how boxy it looked, and that is not the average sunspot right there. So that's a good thing. Unless you don't want to see space weather, then it's not so good. All right, has this refreshed yet? There we go, nice. So there's 131 angstroms, and there's the flare. Perfect. Again, peak flux was about 320. And that's a lot of energy, all right? To emit that much X-ray, that is a very dense series of X-rays right there coming out of the closest star. And again, folks, don't conflate solar flares, which is what you're seeing here. Now, keep in mind, this is extreme ultraviolet. This is not even an X-ray detector. This is extreme ultraviolet. 131 angstroms is the wavelength. So this isn't actually X-rays. You could say it's soft X-rays, maybe. It's extreme ultraviolet light, okay? So don't conflate solar flares with coronal mass ejections. We have solar flares happen regularly with no coronal mass ejection, and we have coronal mass ejections happen regularly with no flares. So they're separate phenomena, and we shouldn't try to establish a causal link where there is no causal link. Is there a correlation? Certainly. Certainly there's a correlation. Does the one cause the other one? Is the other one the same thing as like, no, they're very different things. Photons and protons are very different things. And, that's the fundamentals of physics there. Anybody who can pass junior high physics ought to know this. The difference between photons and protons. It's crucial. All right, anyway, let's look at magnetograms here. We've got some from El Teide. Nice. El Teide, Spain. So here's a nice close-up of the evolution of this sunspot group, if it's evolving. And it's pretty stable there, but I should say it's not stable. It's just not evolving a lot. That is a beefy sunspot, and its likelihood of producing additional X-class flares is certainly there. So let's zoom way in. Just move that over a little bit. There we go. That's not bad. All right, so there's the magnetogram. And you can see this area down here. There's a delta up here now. There's a delta here. Little deltas up here. So this is what you want to see if you like space weather, and we do. So cheers. And thanks for leaving a comment, Stratotanker8373 and Small Baller. But what about the Dow Jones? Oh yeah, I know, right? What about the Dow Jones? Like, who cares about crime when the Dow is up? Oh yeah, that Dow Jones. Oh, I'm so impressed by it and by a certain bureaucrats. Fine job, bureaucrats. A fine job. Pardon my biting sarcasm. My biting sarcasm is bathed in my fangs are pretty moistened due to my biting sarcasm, because it's definitely got plenty to bite. So yeah, there's the magnetic fields of this X-ray, this X-class flare producing sunspot group. There is the red light, that's 677 nanometers. Once again, magnetogram. And let's move on to filaments, because one blasted off, so why not look at more? Now, you may not see the filament blasting off from this, because when they're moving that fast and they come right out of a sunspot, you can't always see them from this imagery. But let's see. I think you can see this one, actually. Oh, no, it's not going to show it. So we're going to use Cerro Tololo instead. Oh, it's even clearer. Look at that. Except it doesn't have the data. All right, let's try. Let's try again. How about Lermonth? 5 days. How about Udaipur? Oh man, for some reason it's 5 days old. Ah, dude, you're killing me here. Seriously? Oh my gosh. All right. Really? Really? Is it seriously not on El Teide? Nope. Oh, brother. What about color images? Let's see if we got the color images. Do you like those better? I mean, I actually like these better, but these don't show prominences. So maybe I ought to just show both. I used to actually show both. But what the hell? 329, 330. Yeah, it should be on one of these. The data from Mauna Loa is only 1,219 days old. Seriously, why isn't it on Cerro Tololo? Oh, because it's even darker there than here. But what the hell, man? Should be on Udaipur. It is not. It's just missing. Brilliant. Look, check it out. 330. There's 344. That's about 15 minutes after the flare. So, I mean, at least there's an image. Jeez. All right, look, I'm going to Helio Viewer. All right. Here's there's 94 angstroms. Everybody's trying to look at this same image from 320, of course. Here's 131 angstroms. Let's remove this other layer. Boom. What's up with that? Let's go back minutes at a time. Oh man, it's just loading and loading and loading and loading. It looks like it's overloaded. Everybody's on Helio Viewer. So let's just how about 304 angstroms? We'll take a quick look here. I know Goes 19 shows it. You get some idea of that plasma discharge there. It's quite a bit of material blasting off. You can see a little bit of limb darkening, but not so much. You can see the material moving through the corona a little bit. Um, but yeah, that's sort of quite of a long duration flare there. And then you can see this hider flare right in here, right on that frame. You can see a bunch of plasma splashing back down toward the chromosphere there as it succumbs to the pull of gravity, as its counterparts blast off into the solar system at like 1,300 kilometers per second. All right. Anyway, got to move on here. Got to get completed on this video. And by the way, if you don't follow us on Twitter, you'll miss a bunch of exclusive stuff. It's the best place to share auroral imagery. So it's, is it good? Is it good as far as being social media? No, it's terrible, pathetic trash, corporate trash, social media. It's full of AI trash. And unless you use things to clean up your subscription feed, you're going to see a whole bunch of crap that you don't want to see because it's algorithmic, junkware powered sludge trash. So there's that. It's AI sludge trash. So yeah, there's that. And basically there's a bunch of trash AI that's being trained on literally everything you do from scrolling and everything else. But all the social medias are like that. They're all corporate cesspools of nonsense. Anyway, the electron flux is, but no, it is a good place to share information because there is an actual space where there's community there. There are people that actually provide an answer to all the science misinformation, disinformation, misrepresentation, and fraud on Twitter. Some of us are there trying to occasionally like be the voice of sanity and try to lower the ignorance level a tiny movement of the needle. But yeah, but that's yeah. So I mean, we're on Facebook as well. I'm usually only on Facebook as myself, but all my posts are public, so you can see all of my posts, believe it or not. Uh, anyway, the electron storm continues, and don't expect it to subside anytime soon. We're going to see bad GPS performance, all kinds of communications funkiness. There's a war in the Middle East going on. So there's all kinds of stuff happening all at the same time that are going to contribute to all kinds of things. And it's going to look very sketchy. And people are going to say it's China and it's Russia. And frankly, I don't know what it is at this point. But Now, let's talk about the total electron content forecast because this has been purported to be a pre-earthquake signal, a way to forecast earthquakes. I want to address this briefly in this video, but I don't want to spend a whole lot of time on it because, well, because we can't use space weather to forecast earthquakes. And if we would, if we could, we definitely would, because somebody wants to win the Nobel Prize for forecasting earthquakes and get insight into the physics, into like causal effects and correlations and the way the ionosphere acts sometimes before earthquakes and the forecast window and what a forecast is and all these sorts of things. But the total content forecast is going to show you where your GPS is like at the very least. Most people who live around the equator are well aware that, you know, your GPS might not work very well between like 10 a.m. and 2 p.m. But in any case, those are the places you can expect to see bad performance. Now this is the DRAP, the deabsorption regions predictions map. And keep in mind, this is just a predictions map. This is not like a measurement of the ionosphere itself. But as you can see there, it shows estimated recovery time. Now, don't be surprised to see a proton event that creates an enduring polar radio blackouts. That's actually becoming more likely because the sun is so active at this point that we're actually very likely to see polar radio blackouts from a solar energetic particle event. We just haven't had that event yet, but we're certainly becoming more and more likely to see one because when the sun's super active like it is right now, SEPs are more likely. It's as simple as that, more or less. And anyway, here are the layers of the ionosphere. This is where space weather begins, folks. Below this is Earth weather, as the atmosphere is mostly neutral. From the D layer on up, the atmosphere is mostly ions. That's where space weather begins. Things happening below the D region aren't space weather, and things happening at or above the D region are not Earth weather. That's why we have a different term. So anyway, now I want to bring up some different maps here that we don't always show, but we're going to look at the F layer, the anomaly in megahertz from a 30-day median, the previous day at 1 hour per second, and the same thing with the raw ionosphere map. All right. Now, X-rays make it through the F layer, and they get attenuated by the D layer of the ionosphere. So that the X-rays, they have to, that energy, the electromagnetic radiation, the photons that are the X-rays, they don't make it all the way to the ground level, folks. But they do cause the D layer of the ionosphere to become perturbed. And at that point, your radio signal goes into space instead of effectively reflecting off of the D layer. This is not the D layer. This is the F layer. I've been looking for a D layer map, and I don't know. I'm gonna do a search for you right here on the live stream, just because I want to show you what the process is like trying to find the data. D layer ionosphere map. So when you search for that, the first thing you're going to get, at least on DDG, is deabsorption region predictions map. All right. This isn't what we're looking for. These are not the droids for which you are looking. Now, all right, Solar Ham. Maybe Solar Ham has a link. Nope, same thing, just the DRAP. All right. See, it's always talking about the F layer, deabsorption predictions. I'm not sure that we actually have a real-time map of the D layer. So that would be a Methoscoph. I'm just going to abandon that at this point. But that'll be something that we can come back to at a later time, perhaps on the channel, talking about the D layer. Do we have a map that'll actually show us measurements of the D layer? In any case, these are actual measurements of the F layer. And again, keep in mind, those photons make it through the F layer. The F layer is more diffuse than the D layer because the D layer is at a lower altitude. So again, there's that map. This is the layer the radio signal bounces off of. This is the layer that's measured with the GOES electron flux and with these HF maps that we're showing. So this is a megahertz of the F layer, or F2 layer on the daytime side. And the units expressed here are megahertz. So it's the vibrational frequency of the ionosphere, the material in the ionosphere. It vibrates, and that's what it's showing you on the map. And you'll notice there's no signal there on the F layer map from the time of the solar flare. All right. And that's what you would expect, because the X-rays, they affect the D layer, not the F layer. There's a different molecular density to the D layer than to the F layer. So you're not seeing a signal there. You may see a signal like in here somewhere around 320, but you don't see a signal there. So there's a reason for that, folks. And it's because the F layer isn't really affected by it. The same way you don't get the X-rays affecting you on the ground, only they're not going through you. They're not making it to you. So some of the stuff is counterintuitive, folks, about what happens with radiation and particles when they make it to Earth. But this is anomaly in megahertz from a 30-day median. And yeah, we're going to see major anomalies in the coming days because major space weather is back. It's back, and it's coming hard. Now, I just put together a different map here because I just wanted to take a look at this at a higher temporal resolution. But it's pretty much a non-starter, folks. So now, we do have a total electron content map. So this is the total electron content itself. And, we showed this earlier in the video. I'm just going to refresh that and play it again because this shows the ground stations. And the ground stations know where they are. So when they talk to the satellite, which also knows where it is, it knows how much the signal has been refracted. It's a time delay. Is it a time delay? Or is it just signal refraction? I'm not sure. But in any case, that's the that's the ions between your handset on the ground and your GPS satellite. So that's like out to the outer Van Allen belt where your GPS satellite's located. And I'll keep it right. Let's see. Here we can show large part of the map there, complete with the timestamps up here. Now at 320, I just want to show you what you'll see if you look at this map. At 320, at least at 315, there's definitely a signal here. Right there, over Indonesia. So there's that. And like a solar flare does ionize parts of the ionosphere. So it increases the ionization. So that is what you would expect to see. Little increase in total electron content there. But yeah, that's a total electron content map. And like that's real measurements. It's not a forecast, it's not a model. It's the total electron content. So anyway, just figured I would show that because I want people to know what they're looking at when they try to look for pre-earthquake signals, all right? Because people seem to think that we're able to use the ionosphere to forecast earthquakes. And yeah, we would really love if that was the case, but it just isn't the case, folks. So I mean, we did have a significant earthquake as we had what was it anyway? It was 7.5 near Tonga, near Tonga. And I got an alert about it. It was I don't know what time it was. I'd have to look at my phone, which I'm streaming on right now. So that's it was that's off the east coast of Australia, Tonga, Tonga and Fiji. They're out in the middle of nowhere there. One of the most desolate portions of the whole world. And yeah, so there was a big earthquake. Was it forecastable? Well, I don't know how you'd forecast it because you'd have to forecast solar flare. So even if, and we're not saying this, but even if a solar flare caused an earthquake directly underneath where the flare happens at noontime on Earth. Here's the flare, here's noontime. Even if the quake happens right there, how are you going to forecast it? You don't know the flare has happened until the light is already there. Because you've got satellites in space that are measuring the X-ray flux. So the flare is already here. If the flare causes the earthquake, you're in effect needing to forecast a solar flare to forecast the earthquake. Now, I'm not suggesting that solar flares cause earthquakes, but if they actually did, you would have to forecast the flare for it to have forecasting value. And we can't forecast solar flares. We give a probability of the flares. I hope that helps. So far, I don't see any predictive value in forecasting earthquakes by this weather. So I keep hearing about it because certain channels keep talking about it, and that causes them to make a lot of money talking nonsense about space weather and geophysics, and then ask a lot of questions, and they demand the science to advance. And because we would really love to see earthquakes forecasted, unfortunately we don't see earthquakes forecasted, because if we did, we would forecast them. And don't say it's a Depop agenda, and don't say Kamala Harris told us about the Depop agenda. I'm aware of your arguments. The problem is that there are people who do science who want to forecast the earthquakes and win a Nobel Prize, and in good faith advance the understanding of the natural sciences. So there's that. Now I'm going to put your chats on the screen here. I saw a whopping like 2 comments on this video. Typically when we see major space weather events, we see less views on our channel. Yeah, that's right. We see less views. I imagine it's because people are paying for lots of ads, which then take our views away because they're purchasing views and we're not. So I'm pretty sure that's what actually happens, because the market for space weather content is only so big. So if somebody purchases all of the ads that get their channel recommended, it gets on somebody else's screen besides yours. So enjoy that. Am I going to start dropping a bunch of cash on ads on YouTube so that people actually see the videos? Well, absolutely not. Now that we've talked about the ionosphere, let's transition into Earth weather. Here's the sunrise over the lovely Atlantic. I love it. Your father loves it. Your Aunt Netta watches it every night on the VCR. Yeah, I'm going to put your comments on the screen here, folks. And guess what? I can't see my own video now. I've pressed refresh. Oh, there I am. Nice. So it wasn't there, and then it was there, and now it's there. And I think she said, take your bra off. That's a way to start out the commercial with an edgy thing. Right? Great. I wonder if anybody purchases ads that will get you just, would you like to purchase a deluxe bot package, sir? I know, right? Would you like to purchase a deluxe bot package? Exactly. That is the question that every purveyor of social media fraud would like you to waste money on. Seriously. Would you like some more sludge trash to go with your sludge trash? We want to write your sludge trash script and make your sludge trash thumbnail so that you look so professional by having AI write, by using machine learning, your script, your titles, your thumbnails, and maybe then one day you can aspire to be a bot. Congratulations. Maybe one day, if you use enough AI sludge trash on your channel, you can be a bot. Wouldn't that be exciting? Now, I show 0 viewers, and I'm not too surprised because I'm a little bit critical of the AI sludge trash. Hey, look, there's Barbarian 1111. Hi. And thanks for stopping by. Now I'm going to put a link to the homepage right there in the chat, and I'm going to pin that message so that it just stays up there. Now, I don't know who designed the default settings for YouTube comments, but I'm pretty sure that person may be a sociopath, or perhaps a psychopath, or perhaps a sociopathic psychopath. But in any case, there's the lovely sunrise over the Atlantic. And over most of the country, because we're coming at you very late with a pretty long stream today, here at the Smash Network, least busted name in news. And if you'd like to support the channel by sending us a super chat, or perhaps picking up some merch, you can find links on the homepage at smashomash.com. If you're new to the channel, don't forget to press the subscribe button and tell your friends and foes by pressing share. We've only been producing the world's most comprehensive daily space weather content for like 7 years now. So no big deal. We've only been forecasting solar storms and all kinds of other things with the same accuracy as NOAA and NASA and ESA. And, well, frankly, that's it. We've been forecasting with the same accuracy as the space agencies. Is that good enough for you? It's good enough for tax dollars, apparently, because anyway, if we could advance the science, we certainly would. And this is done in good faith because we noticed that there was no acceptable content about space weather on YouTube. So we started making our own videos where we talk sanely about the subject and do things like actual forecasts and actual explanations of how things actually work. Crazy, right? But that's what you do when you're the least busted name in news. You cite facts and you let the chips fall where they may. Now that we showed the sunrise over the Atlantic, how about the water vapor map for the entire Western Hemisphere? Well, sort of. This third of the Earth, it's the goes east. And there is a big gradient happening right now in Brazil. Look down here. Check this out. Look at all that dry, massive air creating this huge front here. There's an atmospheric waterfall happening right there. Here, let's do a close-up. Atmospheric waterfall. On our next disaster film, the atmospheric waterfall of Brazil, where you too can be spooked simply by looking at a map. And if you zoom all the way in, you can be even more spooked. Meanwhile, dummies who don't know how weather works, they'll tell you that that's a chemtrail because they don't realize that a 3,000-mile long weather front cannot be a chemtrail. But they'll tell you it is all the same because that's what dummies do. They don't understand science, and then they make extraordinary claims backed up by nothing. One man, one atmospheric waterfall. Bruce Minas of Brazil. Bruce, where'd you ever learn to kayak? I thought you were a bat. The Brazilian waterfall, not to be confused with a mullet, coming to a weather pattern near you. If you're in Brazil. Anyway, yeah, we've got a bunch of moisture on the west part of the U.S. and pretty clear situation over the east part of the U.S. And let's continue on because this video is getting lengthy and my voice was shattered before I even started because I was raging and yelling about other crap. And there's certainly plenty of crap. Like, here's some crap. I can't tell how many viewers are in the stream. So I see people comment and then I go, what the hell? How am I getting comments with 0 viewers? Wow, isn't that amazing? Could it be because you what's your actual views so it can shortchange you? Would be surprised at this point. Would you be surprised at this point, folks? If somebody was ripping you off, like, would that surprise you? Are there enough fucking scams right now? Like, seriously, do we have enough fucking scams? I'm pretty sure we're maxed out with the scams. If you're thinking of starting a business, which is actually a scam, please don't. I think the market's saturated. Speaking of saturated, there's the U.S. Doppler radar map. And what this shows is vertical motion of the air column, like raindrops or snow and ice. Vertical motion. Today's forecast is as follows. Lehigh Valley, slight chance of rain showers at 3 p.m. with a high near 73. It's going to be beautiful. Tonight, showers mainly after 10 p.m. A low around 47, so another warm night. What the hell? What? What are you talking about? Oh my gosh. I'm reading a... Seriously! Forecast.weather.gov's page cannot be found. What a surprise. What a surprise. You know, because the government is such a good steward of your tax dollars, isn't it? Let's try that again. Today, scattered showers mainly between 1 and 5 p.m. with a high near 63. Sorry about that. Scattered showers and thunderstorms, possible at 2 a.m. Tuesday, a slight chance of showers and thunderstorms before 11. Wednesday, rain before 11 a.m. That sounds pretty shisty. That sounds like pretty shisty weather. Anyway, let me put your chats back on the screen as I see some have come through. It's always interesting trying to figure out how many people are viewing the video because I see comments come through and then I see the number 0 for the number of viewers because YouTube has never been worse at existing because it's software and it's terrible and barely functional on its finest day. Really pathetic. I mean, Google doesn't have enough revenue to create a functional app. You know, Google cannot afford to make an app that functions, folks. And they're totally not alienating business customers with the way Google behaves in running YouTube and search and everything else that it, quote, does, end quote. I have here, I see, what is this? How about if I nice satellite map of the U.S. and shrink it down nice and small and put that over there? There you go. That's not too bad. That's pretty good. There's a nice satellite map of the U.S. And there are your chats. Actually, California's southern coast is beautiful today. Oh, must be nice. Must be nice to be able to do anything. Barbarian 1111. Congratulations. Small baller. Rage over $499 Trump watches. I think I've got bigger fish to fry than Trump's latest cheap watches marked up because they have Trump's face engraved on them or something. I'll pass. Closed up shop, never been happier. I don't know what that means, but congratulations, Barbarian 1111. Okay. So, hey, how about an ad from Windy.com? I haven't seen enough ads by being on YouTube. Have you seen enough ads on YouTube, folks? Right as I reach our 1 hour mark, I'm reminded of what the ads are like on YouTube nowadays. Have you seen ads that are like a half hour long now? What YouTube channels are just putting out their podcasts as ads? I've seriously had like a half hour ad. I'm not even kidding. There's like something playing that's like an hour and a half long and I'm doing something and I have to like go press skip or I'm like watching another channel's podcast for some reason. Like what? YouTube doesn't even have the common courtesy to like tell me how long the ad is going to last or something. Like on Spotify, for example, the ads happen and they're there for like sometimes it's like a minute and a half and then it's like ad free for a half hour so that you can like know what the hell is going on. Like sometimes I'll be upstairs and I'm like, who is talking? What is this podcast? Like and it's imagine what the political ads are going to be like in 2026. Imagine what October is going to be like on Facebook and YouTube and stuff with the midterm elections. All the Trump-backed Republicans are going to get absolutely shellacked in the midterm elections, or I should say, collections of everybody's cash to go waste money on campaigning. I mean, just wow. It's mind-boggling. The allocation of resources is currently unacceptable. The allocation of resources is currently unacceptable. And I suspect it's going to, like, I forecast it's going to, because if it doesn't, the forecast is even worse than if it does. So yeah, I don't understand the levels of incompetence that I'm seeing, but I'm affirming them. Check it out. It's very dry. Very dry. And I think very hot too, isn't it? Anyway, there's a temperature map for the US. And we'll close out this video with a lightning map. We got some lightning over the Gulf. Shout out to our viewers from Nolens, Laplace. Hey, Lutcher. You got some thunder rolling in there, Lutcher. Also, the Louis Armstrong New Orleans International Airport seeing some lightning. Those cells are to your southwest. Oh, there's a strike right by the airport, folks. Right in the bayou, folks. Anyway, realtimelightningmaps.org could save your bacon. Lightningmaps.org. It's pretty good. That data is only 2 seconds behind. You can forecast thunder. I kid you not. It's a real son of a bit turn when things happen and people can't forecast anything. So we like to cover stuff that has predictive value on the channel. That's one of the reasons why we don't talk about certain things and we do talk about other things, because of the predictive value. Now, when it comes to weather forecasts, they're a little bit too easy to forecast. So out to 3 days, your GFS model is going to be pretty in agreement with the Euro model or the ICON model. So I'm just going to show one map today. It's just the pressure and precipitation map. Here's your 72-hour GFS forecast from tropicaltidbits.com. Tropicaltidbits.com. And look at that, there's an ice storm coming. Dude, look at that. Major ice storm coming into April in central Wisconsin. Dude, your cheese is going to have ice on it, y'all. Look at that. That is significant ice accumulation on the map. Now, that could change because freezing rain is a little bit sensitive, but so is your car to crashing. So don't do that. Please don't drive in freezing rain. There could be some coming. Don't ruin the rest of your spring by totaling your car and driving on ice. Let's close out with some imagery of the closest planet. real-time data for you. The jet streams of the central world. Yowzers. Here are the surface winds. And hopefully shipping is not being harassed in all kinds of international waters in certain places. Because if it is, it's going to become increasingly hazardous for everybody's health, literally everywhere on the entire planet. And I'm getting pretty fucking sick of it, frankly. Let's go this way. Here are the surface winds of the east. Shout out to our viewers from this side of the planet. As YouTube still shows us 0 viewers, I'm sure it's probably just a little bug in the program, folks. And bear with them. They're a pioneer in, quote, AI, end quote. So don't worry. The AI utopia is coming. Before that, they'll create a smartphone app that functions. Here are the jet streams of the Eastern world. Tripled up jet stream over the South China Sea. Here are the jet streams of the West. And what's next? Hopefully not more travesties and utter failures of your, quote, elected and, quote, officials, end quote. Yeah, like, you got to use quotes on everything now. Elected officials. That's what I think that's going to have to be the new thing. Elected officials. I'm a conscientious objector. I don't give a Anyway, once again, the jet streams, and there are the surface winds of this side of the planet. Here's what's going on the closest star. Have we had any more large solar flares, folks? Well, the answer is no. It's been pretty beat since then. So, let's take a look at that flare in 195 angstroms. It might do a great job of showing the filaments. So there it is. Pretty sweet. And the Earth really picked a bad time to eclipse there because we missed a bunch of data there as a result of that eclipsing of the GOES 19. So that's kind of... Although it could represent an interesting opportunity to see a partially filtered sun. What do you got? Look, partially filtered sun, right? And right there. It's refraction caused by Earth's atmosphere or something. Yeah, no, it seriously is. I'm not kidding. I'm not pulling your chain. So, yeah, in 195 angstroms. And yeah, enjoy. Be prepared to start out April Fool's Day not looking like a fool, not looking fooled by anything. And, wake up early in the morning on April 1st. You might have mid-latitude aurora. It's going to be an extended major geomagnetic storm. So always excited to hear that. We'll close out the classic. Well, let's actually look at 171. We didn't even look at 171 yet, folks. How did I miss that? It's the house favorite wavelength. All right, so here's the flare, which doesn't really show up well in 171 angstroms, but it does show the reorientation of those magnetic fields. So we're going to bring this back a few times, and then we're going to zoom in on that area. And of course, the 171 angstroms wavelength gives us some insight to the reorganization of those magnetic fields, because that species of ionized iron orients itself. Those particles orbit those magnetic field lines, which is why it looks that way. All right, let me rock this back a few times. We'll start from about 130. So 171 angstroms is very picturesque. Keep in mind, it's a very specific ion of iron that emits that extreme ultraviolet light. It's only visible from space, which is why we have to use things like the GOES 19 to see it. The GOES 19 is at like 26,000 miles of altitude. So it's definitely in space, like space. Like astronauts don't go to that part of space unless they're going to the moon type space. Anyway, there's the full disk view. We'll close out with a full run here of 304 angstroms rather. Check it out, a crown prominence going on there. Another feature you see around solar maximum. So big solar storms, big prominences, lots of sunspots, lots of activity, high likelihood of solar energetic particle events, big incoming geomagnetic storm. That's what you want to see around solar maximum, and we're delighted to have you. So thanks for tuning in. Congratulations on Realize the channel exists. Press the share button because this isn't getting on anybody's screen. According to YouTube, I've seen 0 viewers on this. So I think it's actually a bug, because if I see people typing comments, they're probably viewing the video. But who knows? Who knows? The apps are completely broken. These are not the droids for which you are looking, and there's no there with your quote AI and quote. Hopefully the fraud will cease soon in the CapEx, but the AI bubble has yet to burst, I think. And in any case, out, because I'm done ranting for now, but I'll be back again to rant more. So we'll see you soon here at the Smash News Network, least busted name in news. I'll have been your host, Dan, aka Smash-O-Mash, signing off. Till next time, may that major geomagnetic storm be at your back. And then turn around and look at the aurora, because it's going to be awesome. Opinions expressed in this video are not necessarily opinions of Smash News Network, least busted name in Naz.